In a merge sort, we have one array. In array, we have a left pointer, middle pointer, and right pointer. We need to divide our array from our middle pointer. One array from our left to middle, another array from our middle plus 1 to a right pointer. We need to do the same thing again and again until we have a small array, or each array need to have a one element. So now we have a small subarray, or we have an array which only have a one element. Now let's check 7 or 4, which is the smallest one. Smallest one come first. So 4 is the smallest one. So 4, 7. Now we need to do the same thing. 9 or 6, which is the smallest one. 6 is the smallest one, so 6 come first. Do the same thing for 3 or 5. Okay, so 3 is the smallest one, so we need to write 3 and 5. Now we need to compare with 2 and 1. 2 is biggest one and 1 is smallest one, so 1 come first. Okay, so now we have a 4 subarray. Now we need to do the same thing. 4 or 6, which is the smallest one. 4 is the smallest one. 7 or 6, which is the smallest one? Obviously 6 is the smallest one. 7 is the smallest one compared to the 9, so let's write a 7 and 9, and do the same thing for other side of array. Now we have a two sorted array, and in this two sorted array we have a pointer. Now we need to check 4 versus 1, which is the smallest one? Obviously 1 is the smallest one, so let's write 1, and then move our pointer to a next element and check 4 versus 2. 2 is the smallest one. Now we'll move a pointer in our 3, and now let's check 4 or 3, which is the smallest one. 3 is the smallest one, so I'm going to write 3. Now move a pointer and let's check 4 versus 5, which is the smallest one. 4 is the smallest one, so I'm going to write a 4 here. Now let's move a pointer in our 6, and now let's check 6 versus 5, which is the smallest one. Obviously 5 is the smallest one, and move a pointer, write 7, move pointer 9, and that's it. So we just do a merge sort here. Now we are going to implement the same thing in our code. So in order to implement our merge sort, first we need to create an array. So this is our array. So in this array, so after this array, we need to write our merge sort function, and in this merge sort we need to write our array. We need to write a 0, which is the left pointer, and we need to write a 7, which is right pointer. The 7 is the length of this array. Okay, so let's go here and let's write our void, and merge sort, and in this merge sort we need to write a array. Let's write a left pointer, and we need to write a right pointer. Now we need to find our middle pointer. Okay, so if our left pointer is less than right pointer, then we need to find our mid. So let's write L plus R divided by 2. So if our L is less than is equal to R, then we need to find mid, and we need to write a merge sort, and in this merge sort we are going to write our array and from our L to mid. We need to write a mid plus 1 to R. Okay, so these are our array. So we need to divide our array again and again and again until we have a small element of array. If L become equal to R, that means we only have one element in our array. We don't need to divide our array into two parts. Or if we have 2 or more element in our array, we need to divide our array into a sub element or sub array. Okay, and now we got out this two sorted array. First we divided, and when we got a small or sub array, then we need to merge with each other. Now we have a left sorted array and right sorted array. Now we need to pass our sorted array in our merge functions. We need to create this merge functions, and we need to pass our array we need to pass a left pointer, mid pointer, and right pointer. Let's go here and create our function, which is a merge function. And in this functions we have a array, we have a left pointer, we have a mid pointer, and we have a right pointer. So now what we need to do is I'm going to write n1. Let's write mid minus l plus 1 and n2 from our r minus mid. Okay, so this is our left sorted array, and this is our right sorted array. Now we need to make a two temporary array. Let's make a two temporary array, which is array A and array B from array B. Now we are going to add a value in these two temporary array from L to mid. After that, mid to R. So for that we are going to run a loop. Okay, so in order to add a value here we need to run a loop. So let's run a loop. Let's write a int I is equal to 0. If our I is less than n1, then we need to run our loop. And now let's write a array I is equal to array L plus I, and I'm going to copy this and paste it here, and let's write a n2, and instead of A I'm going to write a array B, and instead of L plus I I'm going to write a mid plus 1 plus I. So what we just did is our this array have a two sorted array, one from L to mid and other from mid to R. We're going to merge our A and B array just like this. For that we need to make a pointer. Okay, so our k pointer traverses our main array. Now we need to run a while loop from I is less than n1 and j is less than n2. So let's write if our array I is less than array, if our array I is less than array B, I mean array J, then we need to write array K is equal to I, and let's write a K plus plus and I plus plus. I'm going to copy this BJ and J plus plus. So J pointer reads the last element, but our I pointer did not reach last pointer. So now what we need to do is we need to ensure both pointer reach a last element of our array. If any pointer reach last element, then our while loop will break because we use an operator here. So for that we need to use another while loop to check both pointer reach their last element or not. Okay, so now let's run our while loop again, and if our I is less than n1, then what we need to do is I'm going to copy this and paste it here. So sorry for that. And let's write a n2, and let's write a bj and j plus plus. Okay, so now here I need to run our loop. if our I is less than, so if our I is less than 8, then we need to write cout array I, and let's write a cout end. Now let's run this code, and now we got our sorted array.